Hey guys, so today we are going to be teaching or learning about the law of conservation of matter, and I'm sure that in itself is not new to you guys, but we're going to talk about its implications for chemistry. Now, this is one of those things that's a fundamental law of the universe, and if it doesn't hold true, well, the universe as we know it blows up. So let's stick to the law. Alright, so what's the point? You want to be able to state the law of conservation of matter, but you also want to be able to state its implications for chemistry and chemical reactions. So why do we need to know it? Why is it important? Alright, so what is it? Well, basically, matter can neither be created nor destroyed, only rearranged. Alright, so we don't make anything new. Now, what this actually means is, in an isolated system, so that's a chemical reaction where nothing enters or leaves, then the mass should remain unchanged. And right here we've got an example. There's nowhere for the gases or the chemicals to leave. So the only things which are involved in the reaction is that which is already in their system. So like everything's closed off. I mean, it looks like it could leave there, but it can't. Like a syringe won't allow it. So that's a closed system, which means if we weigh it at the beginning of the reaction and at the end, it should weigh the same. So what are the implications for chemistry? Well, in a chemical reaction, as no new atoms can be created or destroyed. So what does this mean? A chemical equation must have the same atoms on both sides of the equation. So let's look at an example here. Okay, so we've got magnesium. This S means it's solid. Hydrochloric acid, or HCl. The AQ means that it's dissolved in water. Goes to, remember this means goes to, not equals. Hydrogen gas, plus magnesium chloride. Now, or AQ down the bottom, because it's also dissolved in water. So, what we see is that we have magnesium on this side, magnesium on this side. Hydrogen on this side, hydrogen on this side, chlorine on this side, chlorine on this side. There's no oxygen atoms appeared on one side. There was no sulfur atoms on the reactant side that then disappeared. We have the same atoms on both sides of the equation. Now, that almost looks complete. There's one more thing we need to do, and that is we need to balance our equation. Okay, so here is our equation from the reaction before. Let's bring this all up. Alright, now, let's count them. For example, we have one magnesium here, one magnesium there. That's good. Alright. So 1, 1. Alright. Now, hydrogens. We have one hydrogen there, and two hydrogens there. Alright, okay, so that's interesting. We have one chlorine here, and two chlorines there, because this little 2 is only about that one there, so that's a 2 there. Well, that's a problem, because we said that no new atoms can be created or destroyed, didn't we? So this means you have to have not just the same types of atoms, but the same numbers of atoms. Okay, so this is where we do something called balancing it. Now, I might put a 2 at the front of this. Let's see what it gives us. Okay, so one magnesium, that remains unchanged. Well, two hydrogens, because this 2 at the front means the whole unit. Okay, so two hydrogens, we'll get rid of that, and we'll put a 2 there. That's good, that matches our hydrogens over this side. And we've now got two chlorines, because again, that's the whole unit when you put it at the front. So we go boom. Oh, yeah, pen got stuck. Two chlorines. Alright, and that's a balanced equation. Okay, so what this means is, for every one magnesium atom, we need 2 molecules of hydrochloric acid. And this will give us 1 molecule of hydrogen and 1 molecule of magnesium chloride. Well, I mean, molecule's not really right, but we'll stick with that. We've got 1 unit of magnesium chloride. Now, that's it for this one today, but there's actually a second video, and that's with a guy from It's from a video series called Bozeman Science, and he's going to show you in a bit of detail how to balance an equation. Alright, see you in class.